Hello, everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to continue with organic chemistry, some basic principles and techniques. And particularly, we are going to focus because organic chemistry is a vast area, very vast area. And we are going to, in particular, focus on the characteristics of organic compounds in this lecture. Before we begin, a piece of information for you. You can use the coupon codes Mission J or Mission NEET while you enroll at First Online University for Mission J or NEET. Now let us look at what are the different characteristics of organic compounds. Means if we have organic compounds, what are the various characteristics by which we are actually going to identify them? So the characteristics include number one, composition. They mainly contain carbon and also they can contain hydrogen, oxygen, sulfur, nitrogen or halogens. The second characteristic is catenation. The ability of carbon atoms to combine with one another forming long chains or rings is the property of catenation. Third is conduction property. They are bad conductors of heat and electricity. Fourth characteristic is complexity. Most of the organic compounds, they are capable of forming complexes. Fifth characteristic is combustibility. They can undergo combustion. Most of the organic compounds are combustible, that is, they react with oxygen. Sixth characteristic is the melting and boiling point. Now, most of the organic compounds have low melting and boiling points. The seventh characteristic is isomerism. The compounds that have the same molecular formula but different structural formulae are called isomers, and this property of organic compounds is known as isomerism. So if we have the same molecular formula, say I have C3H8, okay, that would correspond to propane. But if I have C4H10, so this C4H10 can correspond to butane, or it can also correspond to isopropane. So butane and isopropane will be called isomers having the same molecular formula C4H10 but different structural formulae. This property of organic compounds is called isomerism. The eighth characteristic is solubility. Now, since we know that like dissolves like, therefore most of the organic compounds are insoluble in water but soluble in organic solvents. Ninth characteristic is stability. Most of the organic compounds are less stable. 10th characteristic is multiple bonds. Since we know that carbon has this property of forming multiple bonds, therefore carbon single bond, carbon-carbon double bond, carbon-carbon triple bond can exist in organic molecules. The 11th characteristic is linkage. Covalent linkage is what is mostly seen in organic compounds. You will never see that organic compounds are ionic in nature, although there are always exceptions existing because chemistry is all about exceptions. 12th characteristic is polymerization. Now, these organic compounds also undergo polymerization. For example, ethene polymerizes to give polythene. We will be discussing this in detail in the polymers chapter. Next is rate of reaction. Rate of reaction depends upon the reactivity of the compounds, and Depending upon the reactivity of the compounds, I mean how fast or slow they can react or how much they are capable of reacting will determine the rate of reaction. Covalent organic reactions are generally slow. Another characteristic is odor. All these organic compounds have a characteristic odor. For example, esters have a sweet, pleasant smell. Amines, on the other hand, have a very fishy smell. The next characteristic is functional group. Functional group is a part of the molecule, or you can say is the characteristic group of molecules which are largely going to determine the properties of that organic compound. For example, we can have the COOH functional group, which is carboxylic acid. We can have aldehyde CHO, we can have CO ketone, we can have OH hydroxyl, and so many of them. They are going to be the characteristic group of atoms that will tell us the properties of that particular organic compound. Another characteristic property or characteristic of organic compounds is the homologous series. So a class of compounds in which successive members are going to differ by CH2 group are called homologous, and this series is known as homologous series. For example, if we talk about the homologous series of alkenes, the first one that we have is methane. You add one CH2 to it, you get ethane. You add another CH2 to it, you get propane, and so on. This is something that has already been taught to you in your 10th standard while we were talking about carbon and its compounds chapter. Now, once we know the characteristics of organic compounds, now let us just classify these organic compounds based on their structure. If I have CH3, CH2, CH2, CH3, now you have 4 carbon atoms in a linear chain. 4 means but, so butane. But when you put it in the cyclic form, you have cyclobutane. Okay, so that's a simple question to answer. This is N-butane, this is cyclobutane. Now, what is the difference between these two structures? This question is answered by simply looking at the structure of these two compounds. If you see, N-butane is an open chain compound, whereas cyclobutane is a closed chain compound. The organic compounds can be classified into open chain or closed chain compounds. Open chain compounds are called aliphatic or acyclic compounds, and closed chain are cyclic or ring compounds. Let us further classify open chain compounds and understand their structures. So aliphatic or acyclic or open chain compounds such as N-butane, and this was what I was talking about in that example when I said for the molecular formula C4H10, we can either have N-butane or we can have isopropane. These are, isobutane. These are the two isomers. And what is the difference between these two structures? N-butane is a straight chain compound and isobutane is a branched chain compound. Now, another classification of organic compounds into open chain and closed chain compounds, and further classification of open chain compounds into straight chain and branched chain compounds leads us to another category of compounds to be discussed, and that is compounds containing heteroatoms like oxygen, nitrogen, sulfur, etc. in the ring of carbon atoms. Pyridine, for instance, is a heterocyclic compound. The compound which contains a heteroatom and is cyclic in nature is a heterocyclic compound. Let us now talk about closed chain compounds. So if I talk of this compound, which is very well known, is benzene. Another resonating structure of benzene can be written in this form, but if you see carefully, this is not benzene. This is actually containing one heteroatom nitrogen in the ring, and this is pyridine. So if we look at this carefully, we will see that in the first structure, the ring is made up of all the carbon atoms. This is a homocyclic compound, but in the second structure, benzene is a homocyclic compound, but in the second structure, if you see, there is a nitrogen that is present in the ring, and therefore it is a heteroatom and it is a heterocyclic compound. So, open chain and closed chain compounds can be further classified into, open chain have been classified into two categories already. Now we are going to classify the closed chain compounds into homocyclic or heterocyclic compounds. Homocyclic are also called carbocyclic because it contains carbons. So let us talk about homocyclic or carbocyclic compounds first. If you look at the first structure, it contains no conjugating double bonds, and therefore this is going to be simply cyclohexane. The other one, on the other hand, is benzene. If in homocyclic compounds, carbon atoms are going to be linked by single bonds, then these compounds are acyclic compounds. So remember, what are acyclic compounds? What are aliphatic compounds? So alicyclic compounds. Acyclic means when you have open chain compound. Alicyclic means when you have in the cyclic structure only single bonds present. So that's alicyclic compounds. Understand the difference between acyclic and alicyclic. So cyclohexane is an alicyclic compound. If homocyclic compounds contain at least one aromatic ring that resembles benzene in their chemical behavior, then we will call these compounds as aromatic compounds. So if you have homocyclic compounds that contain at least one aromatic ring that is similar to benzene, we call them aromatic compounds. Benzene is an aromatic compound. And we already know that cyclohexane is an alicyclic compound. So now we have further classified open chain and closed chain into homocyclic and heterocyclic. Homocyclic can be further classified into alicyclic and aromatic compounds. Let us talk about homocyclic compounds. The first one is aromatic compounds, and these aromatic compounds can be further classified. For example, we have this as aniline. Benzene with an NH2 is aniline. Benzene with an OH is phenol. So we have aromatic compounds that contain at least one benzene ring, which are benzenoid compounds. So let us look at this category where we have another form of compounds which have 7 members, like 7 carbon atoms with a double bonded oxygen, that is called tropone. Or you can also have an OH present along with a double bonded oxygen called tropolone. So they are containing an aromatic ring, but that is not benzene. Aromatic ring because it is satisfying the 4n plus 2 Huckel's rule. It is planar. It is having conjugated double bonds. These are non-benzenoid compounds. So those aromatic compounds which contain benzene ring are benzenoid compounds, and those aromatic compounds which contain an aromatic ring other than the benzene ring are non-benzenoid compounds. So let us now look at the second category, that is heterocyclic compounds, which can be further classified into two categories. Let us have a look at the examples first. So we can have the simple example of tetrahydrofuran, where we have a 5-membered ring and one of the member is oxygen, that is an heteroatom. So it is a heterocyclic compound and its name is tetrahydrofuran. So alicyclic compounds that contain at least one heteroatom. Alicyclic because all of the bonds are single bonds and they are containing one heteroatom in the ring. These are called heteroalicyclic compounds. Another category is when you have double bonds in the ring present. So this is simply furan. This is not alicyclic because you have, some double bonds also present in the ring. So those aromatic compounds, but because it has, alternating single and double bonds, that is conjugated double bonds. So this is going to be an aromatic compound containing one heteroatom in the ring, and they are called heteroaromatic compounds. So now just see, heteroaromatic compounds can be further classified. Okay, let us look through an example only. If we have again an aromatic ring with a heteroatom nitrogen, this is called, and there is a CH3 group. If without CH3 group, it would have been pyridine, but with the CH3 group, it is called picoline. So these are benzenoid compounds, but when we do not have an aromatic ring, which is benzene, for example, azocine, this is a heterocyclic compound, only heteroaromatic, that is called non-benzenoid compounds. So now finally look at the classification. Organic compounds into open chain and closed chain. Open chain into straight chain and branched chain, closed chain into homocyclic and heterocyclic, homocyclic further classified into alicyclic and aromatic, and heterocyclic further classified into heteroalicyclic and heteroaromatic, then aromatic further classified into benzenoid and non-benzenoid, similarly heteroaromatic classified into benzenoid and non-benzenoid. This is going to be the complete flow chart that we have discussed in so many slides. If you have not understood even one of them, go back and revise, because all of these are very basic concepts of organic chemistry that are not going to be asked to you in the form of questions, but these words are going to appear in the questions itself. So because you are required and you are assumed to be knowing all of these beforehand in the form of basics. This is very, very basic of organic chemistry. So understand all of these to be able to answer their application based questions. Now let us look at some questions here. You have to give the class of the following compounds based on their structures. Number one, look at the structure. The name is isobutane. What is the class of the compound? It is an open chain compound. And within the open chain compound, it is not straight chain, but branched chain compound. The second one is pyridine. The class is closed chain, heterocyclic. Within that, it is heteroaromatic compound. Further, it is a benzenoid compound. So whatever we have discussed in the last few slides, based on that, you have to answer these questions. I hope this is clear. Let's move on. The third one, look at the structure carefully. Right now, you might not know the names of these compounds, but slowly and eventually, as we go on talking about aromatic compounds and other organic compounds, you will know their names. The name is naphthalene here. What is the class of the compound? It is a closed chain compound, which is homocyclic. Further, it is an aromatic compound, which is benzenoid in nature. The fourth one is called tropone, which is a closed chain compound, homocyclic in nature, aromatic compound, non-benzenoid. Fifth is azocine, closed chain compound, heteroaromatic, non-benzenoid. Sixth is piperidine, closed chain, heteroalicyclic. Seventh is toluene, closed chain, homocyclic, aromatic, benzenoid. Eighth is furan, closed chain, heteroaromatic compound. Now, what is homologous series? The successive members of the series are going to differ by a methylene CH2 group. For example, a series of alkanes. So if we look at this particular methane, we add a CH2 group, we get ethane, another CH2 gives me propane. Characteristics include their representation by the same general formula, same functional group, successive members differing by CH2 group. Their molecular weight differs by 14 units because CH2 molecule has 14 units molecular weight. Homologues can be prepared by similar chemical methods. And they have similar chemical properties, and they show graduation in physical properties like melting point, boiling point, density, solubility, etc. You can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app for continuous learning through your smartphones. Keep learning with First Online University.